Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 12th. The chapter we are dealing with is application of derivatives, and today is the turn of exercise number 6.3. Now this particular exercise is based on finding the equations of tangents and normals with the help of derivatives for any function, any curve in general, and there are a lot of questions in this exercise. We'll be discussing each one by one, right? So let's begin with the first question over here. Question number 1 says, find the slope of the tangent to the curve this at x equals 4. Now pretty simple question, directly based on finding the equation of tangent for a given point on the curve. Let's say this is a curve y equals fx and there is a point p x1 comma y1 lying on this. You are asked to find the tangent, the equation of tangent at this point. The equation of tangent can be found if we know two conditions. One is this point, which is already known. The second is the slope of this tangent line, and that slope is equal to dy by dx. That is the derivative of this at x equal to x1. If I know these two things, then I can write the equation of this straight line very easily in the point slope form as y minus y1 is equal to m times x minus x1. Mind you, this m is nothing but dy by dx. Right, that's the approach that we can follow and solve all such questions for finding the equation of tangent for any curve at a given point on the curve. So let's see slope of the tangent to the curve at this. Okay, in this question the person is only asking the slope of this tangent. So slope is pretty simple. Y is equal to 3x power 4 minus 4x. Okay, slope is dy by dx, so we'll find dy by dx. What is that? This is 12 x power 3 minus 4. Now this is in general slope. For different values of x you will get different slopes, but the person says at x equals 4 you are interested in the slope. This is dy by dx is equal to 12 times 4 power 3 minus 4. What is that equal to? Let's take a look at this. 4 power 3 is 64, and then you have a 12. 12 also has, let us say, 4. So this is actually 4 power 4, which is 2 power 8. Is it? Let's take a look at this. This is 256 times 3, which is 768. Minus 4, this is equal to 764, and yes, this is the slope. That's the required answer for this question over here. Right? That's all in this question. Question number 2 says, find the slope of tangent to the curve this at x equals 10. So we are asked to find the slope of tangent to this curve. Once again, a pretty simple question. We'll directly find derivative of y with respect to x. Y equals x minus 1 over x minus 2, where x is not equal to 2 because this denominator cannot be 0. This is the domain of this function. Right, derivative dy by dx, what will that be equal to? Now for finding dy by dx, there can be two approaches. One is you apply the quotient rule, and another could be that you could probably write this y as x minus 2 plus 1. The numerator can be written as x minus 2. In terms of the denominator, the numerator can be written as x minus 2 plus 1 over x minus 2, which tells me that y is equal to 1 plus 1 over x minus 2. So the value of y is this. Okay, so dy by dx can be found directly from there, or we can find dy by dx with the help of this. Dy by dx will be equal to what? Dy by dx will be equal to derivative of 1 is 0. Derivative of 1 upon something is minus 1 upon that something square. Minus 1 upon that something square, and derivative of x minus 2 is simply 1. Okay. Now for x equals 10, x equals 10 implies dy by dx will be equal to minus 1 upon 10 minus 2, which is 8 square, which is minus 1 upon 64. That is my answer for this question. A simpler approach of finding the derivative can be seen over here. What about this one? In this particular case, we can solve derivative with the help of quotient rule as well. And how will that help us? Quotient rule will say that this is the denominator, square this denominator. Okay, denominator times the derivative of the numerator, which is 1, minus numerator times the derivative of denominator, which is 1. This is what you will get. Okay, and where is this taking us? This is x minus 2 minus x plus 1 over x minus 2 whole square, which is equal to xx goes, this is minus 1 over x minus 2 whole square. Obviously, we'll get the same thing as you can observe over here, right? But once you're aware of this, you can find the derivative very easily. You can reach this stage very easily. Instead of applying the quotient rule, you have to apply this 1 upon x rule only. And that's the final solution. That's the answer of this question over here. Question number 3 says, find the slope of tangent to curve y equals x cube minus x plus 1 at the point whose x coordinate is 2. Okay, slope of tangent at the point whose x coordinate is 2. Let's talk about this. Y equals x power 3 minus x plus 1. So what will dy by dx look like? This will be equal to 3x square minus 1. This is what it is equal to, right? And we are only interested in the slope, right? Point whose x coordinate is 2. So for x equal to 2, this dy by dx will be equal to what? This is equal to 3 times 2 square minus 1. 2 square is 4 times 3 is 12. 12 minus 1 is 11. And yes, that is the answer for this question. Very simple, yes. Question number 4 says, find the slope of tangent to the curve this at the point whose x coordinate is 3. Okay, once again, you are supposed to find the slope of tangent. Y is equal to x power 3 minus 3x plus 2. So what will dy by dx look like? This will be equal to 3x square minus 3, as you can observe over here, yes. And for x equals 3, this dy by dx will be equal to what? This will be equal to 3 times 3 square minus 3. What is that? 3 cube. 27 minus 3, which is 24. And yes, that is the answer for this question. Question 5 says, find the slope of the normal to the curve x equals a cos cube theta, y equals a sin cube theta at theta equals pi by 4. Now, in this question, we are asked to find the slope of normal. And if you remember that normal and tangents are perpendicular to each other, then the question will be very simple to attempt. And how do we do that? The simple approach is, if this is tangent and this is a normal which is perpendicular, tangent, then the normal will be perpendicular at that point. And if the slopes of tangent and normal are m1 and m2 respectively, so we know something. What is that? That is m1 times m2. This product will be minus 1. For two lines which are perpendicular having slopes m1 and m2, the condition on their slopes is the product of m1 m2 equals minus 1. Now this is a simple condition. On the basis of this, we can find the slope of normal very easily if we know the slope of tangent, right? And the slope of tangent is something which we have been finding, right? But here the curve is given in terms of parameters, parameter theta, so that's not a worry. We need dy by dx, and dy by dx will be simply equal to dy over d theta upon dx over d theta. This is what I'm interested in, right? And what is dy over d theta? So for y, we need to differentiate with respect to theta. A is a constant, A is the least of our worries. Sine power 3 theta will apply the chain rule. This becomes 3 sine square theta first of all, and the derivative of sine theta is simply cos theta. Then next, you have A cos cube theta, differentiate that with respect to theta. A remains as it is. Cos cube theta will become 3 cos square theta, and the derivative of cos theta is minus sine theta. This is what you get, right? Once you observe this much, so some things will get cancelled. A will get cancelled, 3 will get cancelled. Not only that, this sine theta, this sine square theta will get cancelled. What will remain is a sine theta in the numerator, cos theta in the denominator, and there's a minus. So this becomes minus sine theta over cos theta. And what is that equal to? This is minus of tan theta, right? Okay. For theta equals pi by 4, what do you get? This implies that dy by dx will be equal to what? Dy by dx will be equal to minus of tan pi by 4. And tan pi by 4 is 1, which is very simple. This is minus 1. But mind you, this is m1, as you can observe. This is slope of tangent. So therefore, slope of normal will be equal to what? Slope of normal will be minus m2, as you can observe, will be minus 1 upon m1, right? This is what you'll get. This is minus 1 upon m1, which is minus 1 upon this. This becomes plus 1, and yes, that is my required answer for this question over here, as you can see behind me. That's a complete solution for this question over here. Let us discuss question number 6 next. The sixth question says, find the slope of the normal to the curve x equals 1 minus a sine theta, comma y is equal to b cos square theta at theta equals pi by 2. That's what we are interested in, right? Slope of normal to the curve. So let's focus on finding the slope of normal. For slope of normal, the first thing that will require is dy by d theta. That's the slope of tangent, right? And with the help of that, we will be able to find the slope of normal. So dy by dx is what we are interested in. And since x and y are given in terms of parameters, we'll write dy by dx as dy by d theta over dx by d theta. Now what is this equal to? Dy upon d theta. Since y is b cos square theta, this becomes b times 2 cos theta. The derivative of cos square theta is 2 cos theta. And further, cos theta derivative is simply minus sin theta. What about the denominator? In the denominator, we have dx by d theta. The derivative of 1 is 0, minus a is okay, sin theta derivative is simply cos theta. This is what you get, right? And this ratio will be equal to what? You have minus which gets cancelled, you have 2b upon a which is there, and you have simply sin theta. This is what I'm getting, right? 2b upon a sin theta. Is that okay? Yes. Once we are okay with this, therefore dy by dx is okay. At theta equals pi by 2, you will get dy by dx is equal to 2b upon a sin pi by 2. Now what's the value of sin pi by 2? Sin pi by 2 is simply 1. So this is 2b over a. Therefore, slope of normal. Now what is slope of normal equal to? Slope of normal will be negative reciprocal of the slope of tangent. This is minus 1 upon dy by dx. This is what we are interested in. So minus 1 upon dy by dx is this 2b upon a, that is what we are interested in, and this becomes minus a upon 2b, and yes, that is my answer for this question over here. That's a complete solution as you can see behind me. The question 7th says, find points at which the tangent to the curve, we are supposed to find points now, is parallel to the line x-axis to x-axis, okay. Now, this is some random curve, okay, some random curve, and we are supposed to find the points at which the tangent to the curve is parallel to the x-axis. X-axis will be this, let's suppose. So any tangent parallel to the x-axis would be maybe this one or maybe this one, let's say. This is the kind of expression that will get, right? This is one line, this is one line. This is maybe tangent 1, this is maybe tangent 2. We may get more than one tangents, we may get only one tangent, who knows. But what is the special thing about these tangents, and what do we know about these tangents beforehand? If you are supposed to find these points, we should be given some conditions on these points, right? And the important thing to note over here is, since tangents are parallel to the x-axis, you can clearly observe that the angle made with positive x-axis is simply 0. Therefore, slope of tangent is something that is known to us. Since angle made with the positive x-axis is 0, slope will be tan theta, that is tan 0, which is simply 0. And this is the condition that we want to apply. If you can make this out, then the question will be very easy to solve. Slope of tangent is dy by dx, yes. Let's find dy by dx. We are given y, yes. This is x power 3 minus 3x square minus 9x plus 7. This is what you have, right? So dy by dx is equal to 3x square minus 6x minus 9. Okay, and what are we interested in? We are interested in slope of tangent equals 0. Let's equate it to 0, and this gives me, divided by 3, this becomes x square minus 2x minus 3 is equal to 0. Can we factorize this quadratic? Yes. Minus 3, the factors will be minus 3 and 1, which will add up to do this. So x square minus 3x plus x minus 3 is equal to 0. This is what you get. One of the factors is x minus 3. The other factor is x plus 1 equals 0. Okay, and this gives me x equals 3 or x equals minus 1. Now, these are the values of x, mind you. We are supposed to find the points. We haven't yet found the points because we've only found the values of x. The complete information of point will be known if you find y as well. So, for point P, one of the things is x. is something that you have found, and y can be obtained very easily. Yes, yes, yes. With the help of equation of the curve, we can get the value of y very easily. Okay, so therefore, y will be equal to what? Put x equal to 3 in this one. This becomes 3 power 3 minus 3 times 3 square, okay, minus 9 times 3 plus 7. Now 3 power 3 minus 3 power 3 goes, that gets cancelled. This is minus 27 plus 7, which is minus 20. So point here is 3 comma minus 20. Now this is one of the points at which the tangent is parallel to the x-axis. We are getting another value of x, therefore there is another point at which the tangent is parallel to the x-axis. And what's that point? For x equals to 1, y equals minus 1 power 3 minus 3 times minus 1 square, then you have minus 9 times minus 1 plus 7. This is what we have. Okay, and what will this become? This will become minus 1. Yes, this is plus 1 times minus 3 becomes minus 3, this becomes plus 9 and plus 7. 16 minus 4 is 12. So this gives me a point. Point will be equal to minus 1 comma 12. The 2 points that are required, the 2 points at which the tangents are parallel to the x-axis are 3 comma minus 20 and minus 1 comma 12, as you can see over here clearly. That's a complete solution of this question. Question number 8 says, find a point on the curve y equals x minus 2 whole square at which the tangent is parallel to the chord joining the points this and this. Okay. So, in this particular question, what are we given? We are given that point on the curve this is y is equal to x minus 2 whole square. Tangent is parallel to the chord joining the points this and this. Okay. Let a 2 comma 0 and b 4 comma 4 be the given points. Let a and b be the name of these points. Then we are interested in, mind you, those points, and in turn we are supposed to, as we are supposed to find those points, before that we need to find the slope of the tangent. The slope of tangent is exactly same as the slope of this chord. So slope of the chord AB will be equal to what? This is simply y2 minus y1 upon x2 minus x1, 4 minus 0 over 4 minus 2. What is that? This is 4 upon 2, which is simply 2. Therefore, with the help of this, tangent is parallel to the chord, therefore slope of tangent will be equal to what? Since tangent is parallel to the chord, slope of tangent will also be equal to 2. Okay, slope of tangent is also 2. Next, slope of tangent. What is slope of tangent? It is dy by dx, right? And since we know y equals x minus 2 whole square, we can find dy by dx very easily. This is 2 times x minus 2. Derivative of x minus 2 is 1. If this slope becomes equal to 2, we can easily get the value of x. This gives me x minus 2 equals 1 or x equals 3, and this is the x coordinate of that required point. Let's find the y coordinate as well. Therefore, y equals, okay, 3 minus 2 whole square, which is 1. Point is 3 comma 1. That's the point at which tangent is parallel to the chord joining these 2 points. That's the complete solution of this question over here. Question number 9 says, find the point on the curve this x cube minus 11x plus 5 at which tangent is this. Okay. So tangent is y equals x minus 11 implies once again when we are given the tangent, inherently we are actually given the slope of tangent, on the basis of which we can easily find the point on this curve, right? So y equals x minus 11. This is tangent. On the basis of this, you can easily note the slope of tangent, and what is that? That is simply equal to, comparing with the form y equals mx plus c, this is similar, right? So slope is this m, therefore slope over here is simply 1. This is actually m. Okay, as per the formula, this is the slope of tangent. Okay, we are given the slope of tangent, and we can easily find the point with the help of curve. How do we find that? We find the derivative. Since derivative is given to be 1, derivative is the slope, right? So this becomes 3x square minus 11, okay, equated to 1, and this gives me 3 times x square is equal to 12, which gives me x square is equal to 4. And this further tells me that x will be equal to 2 or minus 2. Now, you may observe that we are given we are getting 2 points at which slope equals 1. Okay. We are asked the point at which tangent is this. Okay. And how do we confirm that whether this or both satisfy that condition? So for that we'll have to find y with the help of this equation over here, the equation of curve, and let's see after finding the point which point lies on that tangent, or that tangent passes through which point. That particular point will be our answer, right? So therefore y will be equal to 2 power 3 minus 11 times 2 plus 5. What is that? 8 minus 22 plus 5. And what is this equal to? 8 plus 5 is 13, minus 22 is minus 9. This is what I am getting. Therefore point is 2 comma minus 9. Okay, here we get 2 comma minus 9. What about the point over here? Let's check the point over here. X equals minus 2, therefore y equals minus 2 power 3 minus 11 times minus 2 plus 5 is what I get over here. Okay, this becomes minus 8 and this becomes plus 22 plus 5, which is 27 minus 8, which is 19, and therefore point on this at this location is actually minus 2 comma 19. Now 2 points have been obtained, and at each of these points the slope of tangent is 1, but is the equation of tangent y equals x minus 11 at both of these places? Maybe not, or maybe we'll have to check that. Now which of these points lies on this? For x equals 2, this gives me 2 minus 11, which is minus 9. Yes, this is okay. This particular point lies on the tangent. So we are looking for that particular point at which the equation of tangent is this, and this is the point, which is okay. What about the next one? For x equals minus 2, this becomes minus 13 simply. And is it equal to 19? No, it is not equal to 19. So this is not the required point at which the equation of tangent is this. The correct answer is this particular point. By checking the equation of tangent with respect to this point, that's what we get in this question. Question number 10th says, find the equation of all lines having slope minus 1, okay, that are tangents to the curve this. Now we are interested in all of those lines. First we are supposed to find the equations of lines at which the slope, for which the slope is minus 1. Okay, so dy by dx is given to be minus 1. Okay, what is y? Y equals 1 over x minus 1, which tells me dy by dx will be equal to 1 over something, will be, the derivative will be minus 1 over that something square, and the derivative of x minus 1 is simply 1 by the chain rule, right? This derivative, if this equals minus 1, what is the value of x? Can you find the values of x? Yes. Once you find the values of x, you will get the points, right? Slope is already known, you get the points, and after that it is very easy to find the tangent, equation of tangent, right? So therefore, minus 1 over x minus 1 whole square is equal to that slope minus 1. This gives me x minus 1 whole square is equal to 1, or it tells me x minus 1 is equal to plus or minus 1. Therefore, x equals 1 plus 1 2, or x equals 1 minus 1, which is 0. There are two possibilities. Okay, let's solve each of them separately. For x equals to 2, y equals 1 over 2 minus 1, which implies y equals 1. Okay, point is 2 comma 1 in that case. Slope is something that we already know, minus 1. Okay, so equation of tangent can be found easily. Y minus 1 is equal to minus 1 times x minus 2. Yes, yes. This becomes x plus y, Okay, and 2, this becomes minus 3 is equal to 0. This is the equation of tangent in this case. What about the next one? Let's talk about the next one. For x equals to 0, y equals 1 over 0 minus 1, which is minus 1. Okay. The point, therefore, will be 0 comma minus 1. This is the point over here. Next, slope is already known. It is minus 1. The person has already given that. Equation of tangent, what does that become? Equation of tangent will be y minus of minus 1 and slope minus 1 times x minus 0. This becomes x plus y, x plus y plus 1 equals 0. That is the equation of required tangent over here.